Okay, this isn't going to be a video about the machine itself, but it's going to be a video more about machining. I have a small project I want to make. Basically, I want to duplicate this bolt as precise as I can. This is part of a relatively old brake drum measuring tool. These bolts screw into these pieces and center in these grooves to hold these at the right measurement. You can see that bar has inches marked on it. Basically, if you have an 8-inch brake drum, you would set these both where the arrows point to the 8 on each side, tighten it up with these bolts, and then whatever the dial indicator says would be the exact measurement. So if it says 60, it would be 8.060. The probably challenging thing about this is this little tip here is actually spring-loaded, and it's staked in there with 3 stake marks around the tip of it. The diameter of the piece that's down inside of here is bigger than this. So I'll make the bolt part first, and it'll have to be drilled and then counterbored, and then I'll find a spring that's suitable. I have a pile of springs laying around here somewhere, and then we'll make the piece that goes in there. Then I have to figure out how to hang on to it so it's good and solid to actually stake that to keep the piece in there. So I don't think it'll be terribly difficult, but I'm going to give it a try. Also, not that it's needed, but I'm going to have to use the 4-jaw chuck to do this because, believe it or not, filming kind of screwed me over. I had moved the carriage in that direction to film the wire in the DRO video, and I had my 3-jaw chuck on here, and I forgot how close it was to the tool post. I actually had the tool post pulled back, and it was able to contact one of the jaws, and I turned on the lathe to try to show the RPM in the RPM part of that video, and boom. The next time I chucked something in that chuck, it wiggled. And I played around. I thought maybe I'd bent a jaw, but I put the other set of jaws in it, and I still had to wiggle. I mean, massive run out. So I must have bent the body of the chuck somehow. I found another 3-jaw chuck on Amazon that measures exactly the same. I'm sure this machine had a stock version chuck applied to it when they built it, and I'm pretty sure that's what I found. I think it's a HHIP chuck that I found on Amazon. That'll probably be here. It's out of stock now, but it'll probably be another 2 weeks, and I kind of want to play with this now and see if I can actually make this thing functional again. So I'm going to use a 4-jaw chuck, which means we're going to have to indicate whatever piece of round stock I have laying around on there, and once that's done, everything will just be cut and dry machining. Okay, I got it in the 4-jaw chuck. I got it roughed in. It's not perfect. It's a rough finish, and I'm going to be taking a considerable amount off of this, but I'm not exactly A-Bomb 79 or Dale Dairy setting up a 4-jaw chuck. I get better over time, but you know how it is. So I set the lathe up to 420 RPM. I don't like to run real fast. When I turn it on, though, I notice, as I said in other videos, 420 setup on this actually runs 515. That's how much the RPM chart, how you set your belts up, actually varies on these machines. See, there's some flex there. It always wipes a little bit off on the back run. Now the big diameter is going to be 640. Let's see where we're at. $713. So I have to dial in 36 thousandths. I think I'm going to do another 20. See if that came out right. Okay, now we have to go down to 432, 875 thousandths from this end. And that doesn't have to be perfect. Okay, that's 875. Speed up the feed rate for this. All right. See what that is. $577. So I have to feed 72 thousandths. This would be 30. Slow the feed rate. I think I can take 30 at a slow feed rate. Maybe give it some oil. make sure we're on track. $456. 12 more. Okay, I think next I'm going to drill it. I got to see what size springs I have that I can put in here. I was thinking a ballpoint pen spring, but I think this is stronger than that. Then after we drill it, we have to plunge in here with a parting tool and make this relief. Out here we can turn. I don't have any kind of form tool to get in here and anything other than a parting blade, and I'll hold my breath when I do it. I crashed this puppy parting, and that would have been the first video where I had to put new bearings in the spindle. Well, I went through my spring stock and I found this little bugger. Feels about right as far as tension. I don't want to pop it out of here and lose it. So I figure, measuring this spring, I have to drill a hole. Let me get my note. Roughly 200 thousandths in diameter. $780 thousandths deep. Now that's going to be a guesstimate because my tailstock doesn't have any kind of DRO measurement on it yet. But I think I'm just going to draw a line on the drill bit. I think that'll be, maybe put a piece of tape on it. That'd probably be easier to see. Because it's kind of got to be right. Because when I make the little piece that goes in there, I got to make sure I have enough room for the spring to collapse, but still push the piece all the way back out. And that little piece is going to be challenging to make because this 4-jaw chuck won't go that small, so I'm probably going to actually turn it, maybe not off this piece, but a piece that's considerably bigger. The biggest diameter on it is going to be somewhere around 230, because I'm going to drill the 200 hole 780 deep, and then I have to drill a counter bore, actually 240 deep, or 240 diameter, 250 deep, because the head of that little pin thing, of course, this sticks out, but inside there's a little part that's bigger, and you see these, I don't know if you can see it, there's 3 stakes that keep it from popping out of there. So I have to make that, if I drill that hole 240, I'll make that piece a couple thousand smaller, just so it moves freely in and out of there. So, put the drill chuck in. I'm going to measure my drill bit and find some tape. Okay, that's about 780. little bit of oil. You know what? Let's center drill that puppy first. This is actually set at 780. Yes, we have a little, I don't know, a little bit to go yet. Just going to kiss it a little bit. I'm a 770. Damn, that's loud. Alright, that's a little bit over, but that'll be okay. Just a couple thousandths. Okay, this will be 242, I think. Okay, now we got to plunge and make this area right here. Not sure about the speed here. See how deep that is. It's 408. We're looking for 340. $34 thousandths deeper. Okay. Now I got to set the lathe up for 14 threads per inch, and that's going to take a while. So, be back in a bit.